Greetings to the Honorable Committee and fellow participant of the 9th IWACP 2020. My name is Yue Dian and I'm currently a PhD candidate studying at University Technology Malaysia. Today I'm honored to be able to present my work titled Shapley-Shubix Index Incorporated Debottlenecking Framework for a Sustainable Food Energy Water Nexus Optimized Palm Oil Based Complex on behalf of my co-authors. The palm oil production chain has the great potential to contribute in the food energy nexus, especially when palm oil shares 34% of the global vegetable oil market. The abundant biomass that can be found at the mill site is eligible for renewable energy generation through CHP system to satisfy the mill demand. Biogas utilization facility is required to reduce the GHG impact in the palm oil mill effluent treatment. By introducing polymer evaporation as an alternative to the biogas facility and including integration between mill and refinery, an integrated scheme known as Integrated Palm Oil Based Complex, known as POBC, was proposed in our previous publications. The optimization of the POBC design is a suitable case study for food energy water nexus evaluation. Therefore, we propose to use the multi-objective optimization to simultaneously consider related objectives such as the maximum economic performance related to the food profit, the maximum net energy related to energy sharing, and the minimum environmental impacts, which includes the minimization of water footprint, in order to generate a food energy water Nexus optimized POBC. Generally, debottlenecking is performed by simulating different process parameters variation in order to target and remove the potential bottlenecks to improve the overall system performance. In reality, there could be so many processes and possible parameters to be considered for POBC debottlenecking. Is it really practical for us to simulate all scenarios regarding parameter changes with respect to every process that exists? Is there a simpler way for us to target only one most impactful process before we perform the debottlenecking process? We should also consider the scenario where different process improvement will contribute into different type of objective improvement as well. In this case, when budget is limited, which is always the case, how should we select which is the most suitable improvement to be made if only one advancement of process is considered? Is there a way for us to select the most suitable debottlenecking attempt considering different objective improvement? Especially now we need to integrate the FEW objectives into our debottlenecking framework. This is where the Shapley-Shubix Power Index, or in short SSI, comes in handy. SSI was introduced by Shapley and Shubix and was known to be used to determine the power of each voter in deciding the final outcome of a voting system. Each voter is required to answer either yes or no. For a similar concept used in POBC, we can now consider that each process can be either operating or failing. By evaluating this system, we can identify the process in which its failure has the greatest impacts towards the overall POBC performance using the SSI complex. Here's a simple demonstration to calculate the SSI for the POBC case study. The POBC considers 5 process stages to form a coalition, and process stage 1, 2, 3, 4, 5 will fail according to this order for the evaluation of the first failing sequence. 3.6 million USD is set as the minimum gross profit that should be achieved by the POBC, and the ultimate goal is to find the coalition that achieves GP lower than the targeted value. For this coalition, the GP is 4 million USD, therefore does not meet the goal set. Therefore, this coalition is known as a losing coalition. Following the failing sequence, when P1 fails, the GP of the coalition has dropped to 3.8 million USD, but however does not meet the targeted goal. Therefore, the coalition is still losing. Subsequently, when P2 fails, the GP achieved by the coalition is now 3.5 million USD, which falls below the targeted value. Since the achievement goal is now completed, the coalition has turned to a winning coalition, and P2 is identified as the pivotal process for this failing sequence, in which this process has the greatest failure impact towards failing the POBC performance target. By evaluating every possible filling sequences and its respective pivotal process, SSI can be calculated as the frequency of each process being pivotal over the total number of possible sequences that can be generated. Finally, the bottleneck process can be identified as the process with the highest value of SSI. This diagram shows the overall debottlenecking framework proposed by our team. Firstly, the POBC case study is input into the fuzzy multi-objective optimization model to generate the fuzzy optimal POBC flowsheet, which considers simultaneously the 5 related objectives. Next, the flowsheet will be evaluated to identify the possible process stages F and possible process stage failure scenario Z. For each scenario, the model will be developed and the optimal results will be obtained in order to input into the SSI calculation stage to allocate the SSI value for all process stages. Next, the bottleneck process or BP with respect to each FEW objective will be determined based on the SSI value. The targeted BP will now be used to perform the debottlenecking of the POBC to generate the final debottleneck flowsheet for the POBC. Moving into the fuzzy multi-objective optimization stage, the fuzzy optimal POBC flowsheet is generated by solving the single objective and fuzzy multi-objective POBC model consecutively, considering 5 objective functions. Details can be found in the publication available at this link. Subsequently, the fuzzy optimal flowsheet generated will be evaluated to identify the significant set of process stages defined as F. The possible process stage failure scenarios Z will also be defined from different working combination of process stages using the Excel spreadsheet. Mathematical formulation for all scenario Z will be formulated and solved in games with respect to the targeted FEW objective. The optimal result will then be fed into the Excel spreadsheet to generate various filling sequences in order to identify the pivotal process and finally the SSI value for each process stages with respect to each FEW objective targeted. The SSI value generated is used to determine the bottleneck process BP with respect to each FEW objective. The BP will then be targeted for debottlenecking by improving one process parameter related to the selected process and to be inputted into the fuzzy model to generate new optimal results to be compared with the old result. The comparison will help to determine whether the flowsheet has been successfully debottlenecked. After that, the procedure will be repeated for other FEW objectives to generate respective debottleneck flowsheet as well. The diagram shows the fuzzy optimal flowsheet generated using the proposed mechanism and will be fed as the case study into the debottlenecking framework. As we see, 5 process stages is identified in this optimal flowsheet. This table shows the SSI and bottleneck process allocated for every single FEW-related objectives. As we can see, the nut canal separation and CHP process stage is the most influential process stage for all the FEW-related objectives. Therefore, it will be selected as the targeted process for debottlenecking later. To perform debottlenecking of the selected nut canal separation and CHP process stage, we have improved the process parameter of boiler efficiency. The improved result shows improvement in the overall POBC economic potential and net energy as well as the overall degree of satisfaction between all 5 objective functions. This result concludes that the debottlenecking has been achieved for the targeted objectives with respect to the bottleneck process determination and that the performance changes has matches the SSI evaluation presented in the previous table. Thank you very much for attention and IWACP committee to give me this opportunity. Any comments and questions are welcome through the email stated.